10:45 तक अरेंज करो। ओके, फर्स्ट ईयर नम्मा, फर्स्ट ईयर ना केमिकल बॉन्ड so hydrogen bond, so hydrogen bond is also called protium bond। बढ़ाने पर ठीक है। so hydrogen bond is also called protium bond। बस होता protium bond because so hydrogen is called protium, hydrogen is called protium, simple hydrogen is called the protium। once again, chemical bond, hydrogen bond, so hydrogen bond is also called protium bond, protium bond। so why hydrogen is called protium? now definition देखो, definition, the chemical bond formed in between, chemical bond formed in between, formed in between high electronegativity, high electronegativity atoms like fluorine, oxygen, chlorine, nitrogen and low electronegativity atoms like hydrogen, so hydrogen, now once again hydrogen bond is also called protium bond because the hydrogen is called H11, hydrogen is called protium। so what is the definition of the hydrogen bond? so what is hydrogen bond? the chemical bond formed in between high electronegativity atoms like fluorine, oxygen, chlorine, nitrogen, chemical bond formed in between high electronegativity atoms like fluorine, oxygen, chlorine, nitrogen and low electronegativity atoms like hydrogen, so it is called hydrogen bond, okay, which is also called protium bond, okay। so this is the definition of hydrogen bond, okay। now so types of hydrogen bond, types of hydrogen bond, types types of hydrogen bond. So hydrogen bonds are of two types. Hydrogen bonds are of two types. First one, intermolecular hydrogen bond. Intermolecular hydrogen bond. Second, intramolecular hydrogen bond. So hydrogen bonds are of two types. First one is intermolecular hydrogen bond. Second, intramolecular hydrogen bond. Now, so what is the intermolecular hydrogen bond? So intermolecular hydrogen bond is formed. It is formed in between two different atoms different molecules. Two different atoms different molecules. Intermolecular hydrogen bond is formed in between two different atoms of different molecules, and because of intermolecular hydrogen bonds, the molecules are arranged in the chain. So they are collectively called as, so molecules are associated molecules. Example, so pay the attention. Example, first hydrogen fluoride. So hydrogen fluoride. So hydrogen fluoride. So hydrogen. This is the bond. So hydrogen fluoride is the first example. So hydrogen fluoride is the first example, and so hydrogen fluoride contains intermolecular hydrogen bond, and because of the intermolecular hydrogen bonds, now molecules of hydrogen fluoride are arranged in the chain. So they are called associated molecules. Now, because of the associated molecules, the boiling point increases. Not only that, solubility also increases. Solubility and boiling points increase. So once again, so hydrogen bond. So hydrogen bond is formed in between atoms of high electronegativity like fluorine, oxygen, chlorine, nitrogen, low electronegativity atoms like hydrogen. And hydrogen bonds are of two types: intermolecular hydrogen bond, intramolecular hydrogen bond. Intermolecular hydrogen bond now. So how many types? Two types: intermolecular hydrogen bond, intramolecular hydrogen bond. Intermolecular hydrogen bond is formed in between two different atoms of different molecules. Intermolecular hydrogen bond is formed in between two different atoms of different molecules. Now example, so hydrogen fluoride. Now, so hydrogen fluoride molecules are arranged in the chain because of intermolecular hydrogen bond. So intermolecular hydrogen bond is formed. Intermolecular hydrogen bonds are represented by dotted lines. Intermolecular hydrogen bond or simple hydrogen bond is represented by dotted lines, whether it is intermolecular hydrogen bond or intramolecular hydrogen bond. Generally, hydrogen bond is represented by dotted lines. Because of intermolecular hydrogen bond, molecules are arranged in the chain. They are called associated molecules. And because of the association, then intermolecular hydrogen bond, the boiling point, solubility, both are increased. Okay. Now, second one, water. 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 Now, pay the attention here. This is the water molecule. And this is the second water molecule. This is the intermolecular hydrogen bond. Okay. So because of the intermolecular hydrogen bond, water molecules are arranged in the chain. And because of that reason, water contains high boiling point, high solubility. And these are the, you know that. Okay. But here comparison. Hydrogen fluoride also contain intermolecular hydrogen bond. Water also contain intermolecular hydrogen bond. But just now we are received. So both are called associated molecules and boiling points have more and solubility also more. But hydrogen fluoride and contains intermolecular hydrogen bond in solid state, liquid state and in the vapor state also. What I am saying you, hydrogen fluoride contains intermolecular hydrogen bond in solid, liquid and vapor state. Because of that reason, then the boiling point of hydrogen fluoride is very less, that is 19.6 degrees of centigrade or approximately 20 degrees of centigrade. Okay. But water boiling point is 100 degrees of centigrade. It is approximately 5 times than hydrogen fluoride. Okay. So water boiling point is 100 degrees of centigrade. It is approximately greater or more than hydrogen fluoride 5 times. Hydrogen fluoride boiling point is 19.6 degrees of centigrade, approximately 20. But water boiling point is 100 degrees of centigrade. It is approximately 5 times than hydrogen fluoride. Okay. But both have the intermolecular hydrogen bond. But what is the reason? Just now I was told hydrogen fluoride contains intermolecular hydrogen bond in solid, liquid and vapor state, but water contains only intermolecular hydrogen bond in solid state, liquid state, but not in the vapor state. Okay. Water contains intermolecular hydrogen bond, but in the solid and liquid state, but not in the vapor state. So that is the reason, and this is about the intermolecular hydrogen bond. Okay. Now, intramolecular hydrogen bond. Intramolecular hydrogen bond. So, intramolecular hydrogen bond. TB now. intermolecular hydrogen bond is formed, it is formed in between two different atoms, of same molecule, same molecule. Intramolecular hydrogen bond is formed in between two different atoms of same molecule, but intermolecular hydrogen bond is formed in between two different atoms of different molecules. Now, intermolecular hydrogen bond is formed in between two different atoms of same molecule. Now, example, yeah, this is orthohydroxy benzaldehyde. Orthohydroxy benzaldehyde. This is intramolecular hydrogen bond. This is hydrogen bond. This is, it is formed in between two different atoms, but it is in the same molecule. So it exists in the same, in between two different atoms of same molecule. So example, orthohydroxybenzaldehyde or salicylaldehyde. Salicylaldehyde. Now, second one. Now, this is orthohydroxy benzoic acid or salicylic acid. So this is intramolecular hydrogen bond. Because of the intramolecular hydrogen bond do not form the associated molecules. The molecules do not arrange in the chain. They are not called as associated molecules. Hence, they have the low boiling point and solubility. So, intramolecular hydrogen bond, which contains the intramolecular hydrogen bond, they do not have the associated molecules. Hence, they do not have high solubility, high boiling point. They have low solubility, low boiling point because they are formed in between two different atoms of same molecule. Okay, and this is about the hydrogen bonding. Okay, so hydrogen bond, just I will repeat again. Hydrogen bond is formed in between atoms of high electronegativity like fluorine, oxygen, chlorine, nitrogen, and low electronegativity atoms like hydrogen. Now, hydrogen bond is represented by dotted lines. It is weaker than covalent bond. It is weaker than covalent bonds. Its bond dissociation energy or bond energy is 8 to 10 kilocalories per mole. Okay, 8 to 10 kilocalories per mole. Its bond energy or bond dissociation energy is 8 to 10 kilocalories per mole. It is weaker bond and it is represented by dotted lines. Okay, now, so after that types of hydrogen bonding. So hydrogen bond, one more point, also called as protium bond, because so hydrogen H11, hydrogen 11 is called protium, and it is called protium bond. Okay, types of hydrogen bonds. Hydrogen bonds are of two types: intermolecular hydrogen bond, intramolecular hydrogen bond. Intermolecular hydrogen bond and intramolecular hydrogen bond. So now intermolecular hydrogen bond, it is formed in between two different atoms of different molecules. It is formed in between two different atoms of different molecules, and due to that the molecules are arranged in the chain. They are called associated molecules. Because of the association, they have the high boiling point and solubility. And example, hydrogen fluoride and water, you know that. Okay, hydrogen fluoride and water. So comparison to each other. So hydrogen fluoride are the low boiling point than water, because hydrogen fluoride contains intermolecular hydrogen bond. Hydrogen fluoride contains intermolecular hydrogen bond in solid, liquid and vapor state. Hence, its boiling point is less, that is 19.6 degrees of centigrade, approximately 20. But water contains intermolecular hydrogen bond in solid state, liquid state, but not in the vapor state. And due to that, water boiling point is 100 degrees of centigrade, which is 5 times and more than that of the hydrogen fluoride. Okay, which is 5 times than hydrogen fluoride. That is the reason. And this is, intermolecular hydrogen bond. Now, intramolecular hydrogen bond is so formed in between two different atoms of same molecule. Intramolecular hydrogen bond is formed in between two different atoms of the same molecules. Due to that, they do not arrange in the chain. So they do not have the molecules of associated molecules. Hence, they have the low boiling point, low solubility. Example, orthohydroxy benzaldehyde or salicylaldehyde. Second, orthohydroxy benzoic acid or salicylic acid. Okay, and these are, that. Okay, and now after that we are going to receive dative bond or coordinate covalent bond. Coordinate covalent bond. Coordinate covalent bond. Coordinate covalent bond or dative bond. Coordinate covalent bond or dative bond. So, definition. Definition. It is formed in between two different atoms. It is formed. It is formed in between two different atoms. different atoms due to mutual sharing, due to mutual sharing a lone pair of electron donated by one atom is called dative bond or coordinate covalent bond. It is formed in between two different atoms due to mutual sharing a lone pair of electron donated by one atom. That is coordinate covalent bond and dative bond. Okay, it is coordinate covalent bond or dative bond. It is formed in between two different atoms due to mutual sharing a lone pair of electron donated by one atom. It is called the coordinate covalent bond or dative bond. Okay, now it is represented by, it is indicated by arrow mark. So here atom which donates a lone pair, is called donor. Atom which donates the lone pair is called donor. It has excess of lone pairs, hence it is electron rich. Atom which donates the lone pair is donor. It has excess of electrons, hence it is electron rich. Now second one, atom which accept lone pair, the lone pair is called acceptor or receptor. It has vacant orbital. It is electron deficient. So now example. So coordinate covalent bond is formed in between two different atoms due to mutual sharing of a lone pair of electron donated by one atom. The atom, it is indicated by arrow mark. Atom which donates the lone pair is the donor. It has excess of lone pairs, hence it is electron rich. Now atom which accepts the lone pair is called acceptor or receptor. it has the vacant orbital and it is electron deficient. Now, the dative bond or coordinate covalent bond formed in between donor and acceptor. Okay, donor and acceptor. Bond formed in between donor and acceptor is called, so electron donor and acceptor bond. It is called coordinate covalent bond, or it is also called dative bond. Okay. Now examples. Example, first one, NH3 ammonia. Nitrogen of ammonia contains a lone pair excess, a lone pair of electron. So if you donate the lone pair to boron atom of boron trifluoride, boron trifluoride, boron trifluoride. Nitrogen of ammonia contains excess of lone pair, and boron of boron trifluoride contains one vacant orbital and it is electron deficient. So nitrogen donate the lone pair to boron, hence the bond is between nitrogen and boron is called coordinate covalent bond. Here nitrogen of ammonia is the donor, boron of the boron trifluoride is receptor. Now bond in between the nitrogen and boron is called dative bond. Okay. So simple you can say, you can write ammonia boron trifluoride, ammonia boron trifluoride, trifluoride is the one example. Second, hydronium ion, H3O plus ion, hydronium, hydronium ion. How? You know, this is the water. The oxygen atom of the water molecule contains two lone pairs. The oxygen atom of the water molecule contains two lone pairs. It donates the one lone pair to H plus ion. This is called proton. Here, oxygen atom of the water molecules contain the two lone pairs. Now, H plus ion contains vacant S orbital. Okay. So, oxygen atom of water molecule donates a lone pair to H plus ion and form the dative bond in between oxygen and H plus ion and give the hydronium ion and gives hydronium ion. Similarly, third, ammonium ion, NH4 plus ammonium ion. Ammonium ion, just now I was told, ammonia. Yeah, this is ammonia. The nitrogen atom of ammonia contains one vacant orbit, one lone pair, and it donates the lone pair to H plus ion, which has the vacant S orbital. Okay. So now ammonia, nitrogen atom of ammonia has the one lone pair, and H plus ion contains one vacant S orbital. So nitrogen donates the lone pair to H plus ion. Nitrogen donates nitrogen of ammonia donates a lone pair to H plus ion, which contains vacant one S orbital and form the dative bond. Okay, and these are the example. First, ammonia boron trifluoride. dative bond is formed in between nitrogen and boron. Second, hydronium ion and dative bond is formed in between oxygen and H plus ion. Third, ammonium ion. Dative bond is formed in between nitrogen and H plus ion. And these are the example for and so coordinate covalent bond and dative bond. Okay, and this is you know that. Okay, now Saturday Vesper theory. Vesper theory. So Vesper theory explain the VSEPR valency. V means valency. S means shell. Vesper theory valency. S means shell. E means electron. P means pair. R means repulsion. Repulsion. Valency shell, electron pair, repulsion theory is called Vesper theory. Okay. VSEPR, Vesper theory means valency shell, electron pair, repulsion theory. Valency shell, electron pair, repulsion theory. Valency shell, electron pair, repulsion theory. Okay? Okay. Right, sir.